Hi everyone, in 4B we're looking at determining the rule for a parabola. So we've already looked at quadratic equations in 4A and also the graphs of the parabola, but here we're kind of working backwards. How do we get the equation given a parabola or given a set of points? I've just put the section summary here because I think it summarizes, obviously, this section quite well. So when we're looking at different types of quadratics, obviously you can have different types of equations. Okay, and there are a few examples here. I think there's 4. But basically, all you need to get a quadratic equation or the rule for a parabola is a series of points. And the number of points you need depends on how many times your parabola crosses the x-axis. So if we look at part 1, or the graph of part 1, all right, we're just sitting on the x-axis, so that means we just can substitute in 1 point. All right, so it's also crossing at the origin. Now don't put in the point 0, 0 because it's not going to give you the value of a. But it is sitting on the origin. You just need another point on the graph, and then you substitute that in for x and y to get your value of a. So we just need 1 point. All right, for the next scenario, we've got 2 points are needed to determine a and c. So here we have a negative parabola. Okay, we've got, oops, sorry, I just highlighted a little bit. It's just been shifted up, so you can see the transformation there. That's a bit of a wonky parabola. I'm just looking there. So we can see it's been shifted up, but it hasn't been shifted left or right. So that's why we've got the plus c. So it's kind of similar to part 1, but part 2, we've got a parabola that's just been shifted up, and it's a negative parabola. Now to get a and c, you do need to substitute in 2 points. All right, if you're given the y-intercept, obviously that's c, which is good. If not, just have a set of simultaneous equations. All right, part 3, here we have both a horizontal and a vertical shift. All right, so we can just substitute in x and y into here. One of the points is going through the origin though, so don't put in 0, 0 because you're not going to get the point there. Just substitute in another point. And then part 4, we need 3 points. Okay, so this time we're not passing through the origin. Okay, so you need 3 points to find a, b, and c. You can use any parabola, so these are in polynomial form, but if you wanted, you could, or expanded form, you could use turning point form, you could use factorized form. It just depends what information you're given. So if you're given the x-intercepts, you could use factorized form. If you're given the turning point, you can use turning point form. So that summary is just showing 4 different possibilities, but there are others. So we'll look at them when we go through the questions. All right, so let's go through some questions in 4B. I'm just going to get a pen ready. All right, you can go back up and have a look and see which one this relates to. So I can actually see here what this point would be. Because a parabola is symmetrical, it is -5. So you could use a factorized form, but I'm going to do it using these ones here. So it's similar to, sorry, just had to look, the second one. So ax squared plus c. So I'm going to write y equals ax squared plus c. Now to get the values of a and c, just have a look at our points. So this point here is 5, 0. And this point here is 0, 4. Now your y-intercept 4 is also your value of c. So c is equal to 4. So I'm going to have y equals ax squared plus 4. And now to get the value of a, I just need to substitute in the other points. I'm going to substitute in 5, 0. So I've got 0 equals a times 5 squared plus 4. So 5 squared is 25. And then I'm going to have a equals, so negative 4 over 25. And there's my dog growling. I don't know whether you can hear her. All right, so we've got negative 4 on 25. So all we do is then substitute it back into your equation. So y equals negative 4 on 25. X squared, sorry, getting distracted by my dog, plus 4. All right, so there's your equation. Now, if you I don't know what, actually I won't. I don't want to make these videos long. I was going to do it factorized way as well. All right, so question B, if we go back and have a look at the different ones we have, it is the same as y equals ax squared. It's just a negative quadratic. So I'm going to, now don't write negative a. We know that a is going to become negative, but it will become negative when we substitute in the point. Now remember, we don't substitute in 0, 0 because you'll get 0. So the other point, this point here, is 2, negative 4. So I'm going to substitute that into the equation. So we've got negative 4 equals a times 2 squared. So now a times 2 squared is 4a. So a is equal to negative 1. So my equation is going to be y equals negative x squared. All right, question C. Now, if we scroll back up to our summary, it is the same as the third one. So ax squared plus bx. All right, so we just substitute in 2 points. Remember, we can't substitute it in the origin because we're going to get 0, 0. So our other 2 points, we've got 1, 3 and negative 2, 0. All right, so I'm going to substitute in, I'm going to do negative 2, 0 first. All right, so I'll just tidy that up a little bit. So negative 2 squared is 4, so 4a minus 2b. All right, we could just leave it like that. Let's get the other equation. So I'm going to substitute in, just put a line there so I don't get mixed up. I'm going to substitute it in 1, 3. So 3 equals a times 1 squared. Now, obviously, you could probably skip this line because multiplying everything by 1. So a plus b. So that means a is equal to 3 minus b. All right, there's many ways you can solve these equations. I'm just going to substitute in 3 minus b for a. So this is our equation 1 and equation 2. All right, so I'm going to just substitute a into equation 1. So I'm going to have 0 equals 4, 3 minus b minus 2b, and then I just solve that. So I'm going to have 4b, so 6b, so b equals a half. So if b equals a half, that means a is equal to 3 minus a half, which is 2.5. Now, I tend to leave things in improper fractions, but it doesn't matter. I'm just going to have to get more room here. Oh, what happened to my... I move things and my Anyway, sorry. Here we go. All right, so your equation is y equals a is 5 on 2 x squared plus b, which is a half x. And you could probably tidy that up. I'm just going to leave that there, but actually you probably should you could put everything over 2. I'm just going to leave it like that, just timing wise for the video. D is very similar. Okay, so you would use, let me just go back up here, y equals ax squared plus bx again, and your 2 points got -1, -3, and 2, 0. I know you know it, a is going to be negative. Don't make a negative. It's going to come out as negative. Just leave it like that and substitute your points in. All right, for part E, let's scroll up here, back to the top. Okay, so it's going to be the 4th type. So ax squared plus bx plus c. So I'm just getting my thing ready. Ax squared plus bx plus c. Now you could use this for all of them because all the previous ones, I think all of them, go through the origin. Oh no, they did, sorry. So they all go through the origin except for A didn't, but it was just shifted up. You'd be substituting in 0, 0 as well. So that's why when you think, okay, sorry, I'm just going on a bit of a tangent here. All right, so let's say we had the plus C for D. C, remember, is your y-intercept. So the y-intercept here is 0. So you don't need to put the plus 0. Okay, so if you're wondering why there's no plus C. All right, whereas for E and also for F, when we haven't gone through the origin, what am I doing? Sorry. But I can see here that it's gone through the y-intercept at 4. So that means C is equal to 4. Okay, so C is your y-intercept. And the other 2 points, we've got 1 and 4. Sorry, 1, 0 and 4, 0. All right, so we just substitute in, actually my equation is y equals ax squared plus bx plus 4. And then I just substitute in 1, 0 and 4, 0. So I'm going to have 0 equals a times 1 squared, which is just 1, and b times 1 is just b. And then I'm going to substitute in 4, 0, so I'm going to have 0 equals a times 4 squared. Probably didn't need to do that. Could skip that step, but anyway. Oh, and I just noticed I forgot the plus 4. All right, so 16a plus 4b plus 4. All right, so I've got my 2 equations. Here's my first equation, and here's my second equation. I find it easier to do substitution. So with the first equation, I'm just going to say a is equal to negative b minus 4. And then substitute that into equation 2. So 0 equals 16. All right, I'm just not talking so I can concentrate. 16 times 4, is that 64? I'm running out of room. All right, so that's going to be negative 20b minus 60. So b is equal to negative 3. Let me just double check that I've done that right. So 20b equals negative 60. All right, so if b is equal to negative 3, a is equal to negative 3. No, I don't want a to be negative. Where did I go wrong? Negative 3. Oh, no, sorry. Ooh, it's not wrong. Negative 3 minus 4. So negative 3 is positive 3. Oh, I'm still going to get a negative. All right, I don't want a to be negative. So I've made a mistake somewhere. I'm just going to pause to see where I went wrong. All right, I realize where my mistake is. This should have been a plus 4b, which makes that, this is why it's always important to question your answers. Okay, so plus 4b. So we've got negative 16 plus 4b will give you minus 12b, and the minus 60 is still right. And let's just fix what we've got around here. So I might just rub that all out. I'll just start again. All right, so 12b equals negative 60, so b equals negative 5. So that means a is equal to negative 5 minus 4. So a is equal to 5 minus 4, which is 1. So I'm going to write the equation over here. Y equals x squared, okay, because a is 1. B is 5, so minus 5x plus 4. And when you think about that, if we were to factorize that, you could write that as y equals x minus 4, x minus 1, okay, because you can do that in factorized form as well. If you did want to do factorized form, you can see that you've got passes through the x in axes at 1 and 4, and you just put an a at the front here. All right, and then you substitute in the point 0, 4, your third point. All right, but I'm just going to erase this a, just because people might think that's the right answer. Okay, so you can put it in factorized form as well. All right, now I think that was an important thing. Oh, it's always important to speak about my errors, okay, because you might make similar ones. So in this case, the plus 4b was, avoidable. It's me not reading it properly. I think for a question like this, that some students would, so b is negative 5, so it's minus negative 5, which makes it positive 5. I think that would have been a common error, but I knew that a had to be positive because it's a positive parabola. So I knew that I had made a mistake without even checking my answer, because it's a positive parabola, but my value of a was negative and I knew it had to be positive. So that's why I went back and checked my answer. All right, obviously we don't have room to do f. All right, but if you wanted to do that in factorized form, actually I might just do that here. All right, even though we're doing it in polynomial form. All right, so we're going to have x plus 1 and x minus 5. And then you just substitute in another point. So your other point is going to be 0, negative 5. And it looks like this is going to be an easy. It just depends on, I guess, what form the question wants you to put your answer in. Okay, I prefer factorized form because I think there's less working out. So if you were to substitute in, I know I wasn't going to do this question, but I don't think it's actually going to take that long to do. All right, so if we're substituting 0 for x, we're going to have 1 times negative 5. So that means a is equal to 1. So your equation is just going to be y equals x plus 1, x minus 5. Don't always assume a is going to be 1. Okay, so you do have to do that working out. It just happened to be that both of them, it was 1. All right, so a lot less working out too. I'm just looking at the difference between those two questions. All right, so the next question I chose, and I'm just going to erase that line there that I randomly drew earlier. All right, so find quadratic expressions for the two curves in the diagram given the coefficient of x in each case is 1. All right, so that's important. I'm going to highlight that. The coefficient of x in each case is 1. The marked points are these. Okay. All right, so I'm going to call this equation 1 or graph 1. Oh, it's not a G. All right, it's a Q. Equation 2. All right, so let's just scroll down a bit so I've got a bit of space. All right, so I'm going to just see what information I have. So let's start with equation 1, just working left to right. All right, so the axis of symmetry is at -4, okay, but I don't know what this point is. I know it goes through the point 0, -5, so I can put that on. And I don't have any other point. Okay, I don't even know where it crosses the x-axis. So I only know it has an axis of symmetry at -1. Oh, sorry, -4. All right, equation 2. Let's see how much information we've got with this one. So point D is 0, 1. And point A is 4, 3. And point B is 4, 1. All right, so if we're looking at equation 2, it's y equals ax squared plus bx plus c. Now remember, it did say in the question that the coefficient of x in each case is 1, so we already know b is equal to 1, and c is your y-intercept, so c is also equal to 1. So for equation 2, we're going to have y equals ax squared plus x plus 1. All right, so all we need to do is solve for a. So we just need another point. We can substitute in 4, 3, or we can substitute in 4, 1. Oh, actually, I just realized 4, 1 is on equation 2. That was my bad. I wonder if any of you realize that. You know, creating these videos, I can't give you chocolates for my mistakes. Actually, it's only if you pick them up before me. All right, so B is on the first equation. Oh my gosh, sorry girls. All right, so let's continue with equation 2 because we're working on that. So we got to substitute in the point 4, 3. Okay, so we got 4 squared is 16. Just got the A. All right, so 4 plus 1 is 5, and then I'm going to subtract that. So we're going to have -2 equals 16a. So a is equal to -1 on 8. So 2 on 16 becomes -1 on 8. So our equation is equal to y equals -1 on 8, x squared plus x plus 1. All right, equation 1. We're doing it second. Okay, so y equals ax squared. Now, we remember the coefficient of x is 1, so it's just plus x. And c is your y-intercept, so it's -5. So I might just, already done that plus. Let me just get rid of that. There we go. Got there eventually. All right, substitute in the 0.14. Sorry, 41. So we've got 4 squared plus 4 minus 5. 4 minus 5 is minus 1. So we're going to have 2 equals 16a. So a is equal to 1/8. All right, so my equation is y equals 1 on 8, x squared. Kind of feel like I've made a mistake somewhere, so I'm going to check the answer. I just think because 1 is 1 on 8. Okay. Sorry, I'm just thinking aloud. All right, I'm going to pause and just check that answer, and then I'll come back. All right, so those equations were correct, which is awesome. I haven't gone back and checked the other ones though, so I'm hoping they're all right. Please let me know if they're not. And I'm going to end the video here, 26 minutes, which is remarkable compared to the previous 2 videos. Anyway, girls, email me through any questions you had trouble with 4B or any other sections, and I'll make sure I cover them too. Bye.